Hello my kiddos, how are you? Welcome to the PW Gulf channel, and today we are going to revise the chapter PMI, Principle of Mathematical Induction. Right, I know that this chapter is not there in the board syllabus, has been deleted, but the aim is also competitive examinations, so let's not skip even a single chapter, even a single topic here on this channel. Alright guys, it's a very small chapter in which only 4 topics are there. Firstly, introduction, what is the motivation behind this entire topic, and it's interesting to know, let me tell you, it's going to be interesting, you'll like it. Then some equality problems, divisibility problems and inequality problems towards the end. These 3 types of questions are only there from this chapter. The very good part of this is, although in subjective it is very lengthy, the objective questions of this chapter tends to be easier, and how and why you will get to know when you understand what is this principle. What principle are we talking about, right? So in this chapter we are going to prove a lot of mathematical relations. What kind of mathematical relations am I talking about? So any mathematical relation we will term as P of n. Let's say you want to add the summation of first n natural numbers. You want to find the summation of first n natural numbers. If you know it already, the answer is n plus 1 by 2. The addition of first n natural number is given by this formula. Alright, is this correct or not? In order to prove that, we will use principle of mathematical induction, in short PMI. Well, this is one example. This is just one example. There are many such mathematical relations which will be proved. So such mathematical relations we will like to call it as P of n. Why n? Because all the things are written in terms of n. N is a natural number. N is a natural number, right? Okay, let's get into the theory, the motivation behind PMI. What is the motivation, from where this sudden new principle comes into picture? So guys, there are 2 types of reasoning. What is this? Okay, there are 2 types of reasoning: deductive reasoning and inductive reasoning. Deductive reasoning, inductive reasoning. Deductive reasoning is logical as well as realistic. But inductive reasoning is logical, may or may not be realistic. Let's take an example to understand this. So as I said, there are 2 types of reasoning: deductive, inductive. Deductive reasoning always goes from a general statement to a particular statement. From general statement, you will conclude a specific statement. Whereas inductive reasoning is the other way around. From a specific statement, you will try to find a general statement. From a specific statement, you will try to conclude a general statement. Let me take example for explaining what I mean here. Okay, right. If I take a general statement, let's say if I take a general statement, all students are naughty, right? I was a very naughty student. What about you? Although I teach mathematics, don't think that I was a studious person. No, not at all. I think with time, with age, as my age number grew, my marks kept on growing parallelly. So when I was your age, I was not at all studious. So all students are naughty, let's say. And if I say, Shina Mina, Vinay is a student. So I've made a general statement, all students are naughty. I've made a general statement. And then I also give you an extra information, Vinay is a student. So if all students are naughty, Vinay is a student, can I conclude that Vinay is naughty? Is this conclusion logically also correct and realistically also correct? It's logical and realistic, deductive reasoning. General statement, all students naughty. Specific statement, Vinay is naughty. So general to specific, deductive reasoning. Let's go the other way around. Okay, now I give a specific statement. Vinay is naughty. And I also give you an information, Vinay is a student. Right. So Vinay is naughty is a specific statement. I am talking about a specific child, a specific student. Vinay is a student. If I conclude from them, if I conclude from these students, from these two statements, students are naughty. Students are naughty. Will that be correct? I mean, logically, there is nothing wrong in it. If Vinay is naughty, Vinay is a student, then I can conclude that students are naughty. I mean, students are naughty. You cannot deny that. But is it realistically true? Some students may be naughty, some students may not be naughty. So it is not realistically, may or may not be realistically true. Logically it is correct. From specific statement, we try to get a general statement that students are naughty. So that's your inductive reasoning. And in this chapter PMI, we are going to talk about inductive reasoning only. See, deductive reasoning you do a lot. I mean, derive the proof, derive this, derive that. In physics, you have done a lot of deductive reasoning. So you all know this deductive reasoning very well. General statement is given, you try to prove it. But inductive reasoning is something new approach here, beautiful approach to solving questions. Let's see what is the motivation behind this principle of mathematical induction. Now I'm taking a stack of Domino's pizza boxes. I mean, very well, it is called as the domino effect. The motivation is nothing but the domino effect. What is this domino effect? Let me explain you in very short. Suppose you have Domino's pizza boxes stacked one behind the other. Like you have to imagine it in 3D, okay? These are some like domino boxes placed one after the other, a lot of domino boxes. If I push one box, if I give a push to one of the box, it will fall on the next will fall on third, fourth, fifth. Subsequently, the last box will fall down. Do you agree with me? If I push the first box, the last box will also fall down, right? Okay. With this is the domino effect. So now if your aim is to get the last box on ground, that is, if you want the last box to be fallen, that's your task. Last box should be fallen. What are the conditions for it? What are the conditions for last box to fall? I'm saying ball every time. Box to fall. The first condition, do you all agree that the first box should fall? The first box should fall. I mean, if first box doesn't fall, how can you make the last box fall? By domino effect. By the domino effect. We are talking about domino effect. So first thing, first box should fall. Okay, is that enough? Only the first ball falls. Now if I say ball instead of box, you understand. Ball is by default box for me now. So if I say that the first box falls, is that enough? Does it mean the last is going to automatically fall? No. So for domino effect, we want that if first box falls, and in general, when any box falls, this is your first box, any box falls, it will make the next box also fall. Any box false will imply that next box also false. If these two conditions are satisfied, it means my last box is going to fall anyways. My last box will be fallen, the task is achieved, the domino effect is executed. Once again, quickly, if I want the last box to fall, first condition, first box should fall. Second condition, every box which falls on the next one should lead the same effect. Every box should fall on the other and the other should fall on the next one. Any box falls, the next box also falls. This effect should keep on happening one after the other. It should keep on happening till the end so that the last box falls. Right? This is your domino effect. This is the motivation behind PMI. Now, in order to solve any question in PMI, what we will do? We will see that the given statement, mathematical statement, the given mathematical statement P of n is true when the task is what? You want to find P of n is true or not. That's your task. Like the task was last ball should fall. Similarly, your task is to find whether the given mathematical statement is true for n. First condition will be P of 1 is true. Can you relate first box should fall? So P of 1 is true. Second condition, if P of k is true, then it should imply P of k plus 1 is also true. That means if any box falls and it implies that the next box, immediately consecutive box, immediately next box also falls. If these two conditions satisfy, we can very nicely imply that P of n is true. The last box falls. Right? If the given statement is true for n equal to 1 and if the given statement is true for P of k, n equal to k as well as n equal to k plus 1, then the given statement can be said is true. It's true for n equal to 1 and in general any value of n. K is any constant. K is any constant. So if you are checking that the given statement is true for k, implies it is true for the next immediate next one also, the given statement is correct. I'll just go back and write down again for you guys. Can you relate? First box falls means P of 1 is true. Last box to be fallen, that means P of n. Any box falls means P of k. Next box also falls. What is the next box? If this is k, next one will be k plus 1. Right. This is the entire motivation behind PMI. I will write down the steps for solving questions. Just write down the steps. First step will be always, whenever you have to find whether statement is true or false, first step will be for n equal to 1, you will check P of 1 is true or not. And how will you check? Whenever you have to check, you will take the LHS, RHS and show that they are equal. Second step, now P of 1 is done. You will assume n of k is n equal to k. P of k is true. You will assume that for n equal to k, assume P of k is true. That means any one box is falling. Third step, what you will do is, for n equal to k plus 1, now you will check whether P of k plus 1 is true or not. If you are unable to understand anything, just copy it down and you will understand in the questions. So put n as k plus 1 and check if it's true or not. Whenever it is checked, that means you will solve LHS separately, RHS separately, and try to find out whether they are equal or not. Also one hint, whenever you are finding P of k plus 1 is true or not, you will always use P of k. You will always be using P of k in order to prove P of k plus 1 is true or not. How? For that you'll have to wait for the questions, isn't it? Once these 3 steps are done, 4th step, you will conclude that P of n is true by principle of mathematical induction. The last step will be conclude. If these 3 steps happen, check, assume, check. Check, assume, check. P of n is true. Statement is true. Done, done. That's all, bye. That's all. Let's first solve some simple questions. This is a mathematical statement. P of n square plus n plus 11 is prime. This is a mathematical statement. Then what is the value of P of 1, P of 2, P of 4? And is the statement true for these values? Can we say that P of n is true for all natural number? Okay. Let's find out, boys and girls, what say. So P of 1 they have asked, putting n equal to 1. 1 plus 1 plus 11, 13, it is a prime number. So P of 1 is true. They have also asked you, P of 1, is the statement true? So we will say the statement is true for n equal to 1. For n equal to 2, the question is P of 2. Put n as 2. 2 square, 4 plus 2, 6, 6 plus 11, 17, which is again a prime number. Then it is true for n equal to 2. What about n equal to 4? P of 4 is equal to 4 square, 16 plus 4, 20 plus 11. 31. Again it is a prime number. So you will say that P of 4 is also true. We have found this. We have said that all of them are true. Is P of n true for all natural number? We cannot conclude the 4th step unless you have done the 1st, 2nd and 3rd step. First step is done, but 2nd and 3rd step you have not done. Putting n equal to k and k plus 1, right? So, but here I'll give you an example. N equal to 10. Just put n equal to 10 and try to find P of 10. It will be 10 square, 100 plus 10, 110 plus 11, 121. Is 121 a prime number? 11 square. 11 square, 121. It is not a prime number. That means P of n is false. And can I say it is true for all natural number? No. P of n is not true for all natural number. We cannot say that this particular mathematical statement is going to be always true. No, it will not be always true. P of n is a statement n plus 1, n plus 2 is divisible by 12. Then which of the following is not true again? Alright, the statement is it should be divisible by 12. Okay, let's check for n equal to 3. What is P of 3? 3 into 4 into 5. 60. Is it divisible by 12? Yes. Put n equal to 4. As I said, the MCQs in it will be very easy. 120. Is it divisible by 6? Yes. The given thing should be divisible by 12. N equal to 5. P of 5 is 5 into 6 into 7. This dot means multiplication, dot product kind of. 3 sevens are 210. Is it divisible by 12? No. So which of them is not true? P of 5 is not true. P of 5 is not true. Are you able to understand? Very good. Next, let's now move to the introduction is done. Equality problems. Introduction, hope you liked, enjoyed 20 minutes of introduction. Now the questions on equality. This is your statement. You have to prove this by mathematical induction. Alright. Let's begin with the step. What was step number 1? Whatever is given, guys, that should be your P of n. I mean, this is your P of n. Whatever statement, mathematical statement, consider it as P of n always. For n equal to 1, what is the LHS? When n is 1, that means only one term from the LHS should be taken. LHS is 1. What is RHS? Put n as 1, 1 square, 1. LHS is equal to RHS. Can I say P of 1 is true? P of 1 is true. Okay, next. For n equal to k, assume P of k is true. What do I mean by this? If P of k is true, put n as k. 1 plus 3 plus 5 plus 2k minus 1 is equal to k square. This is true. Assume. Third step, for n equal to k plus 1. What will be LHS? Whenever you have to check, take LHS, RHS. When you have to assume, LHS, RHS together. Check, assume, check. So LHS will be 1 plus 3 plus 5 plus, put n as k plus 1 minus 1. Now a beautiful thing will happen here. You all will have to appreciate it. If I write 1 plus 3 plus 5 plus and so on till let's say these are odd numbers, so till 21. So do you also appreciate that before 21 there will be an odd number called 19? Even though I don't write it, even if I don't write it, it exists. The dot 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 means there is a number before 21, odd number, which is 19. Okay, if I say 1 plus 3 plus 5 up till a number n. So before n there will be n minus 1. Do you all agree? Before n there will be a number n minus 1. Okay, that's the beauty. Before you take k plus 1th term, there will be a kth term. 1 plus 3 plus 5. Before k plus 1th term, there will be a kth term. Before putting n as k plus 1, before k plus 1, there will be k. So putting n as k and then k plus 1. Well, what is this? What is 1 plus 3 plus 5 plus dot 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 till 2k minus 1? Isn't it your k square, which is already there in step number 2? Put it. It's k square plus 2k plus 1. K square plus 2k plus 1. That's your LHS. Go to the RHS. Put n as k plus 1. Okay, LHS can also be written as k plus 1 the whole square. LHS equal to RHS. Therefore, P of k plus 1 is true. The third step is over. And fourth step, P of n, the given mathematical statement, is true by principle of mathematical induction. By following all the steps, you can say the given statement is true. Good. Next, by using principle of mathematical induction, prove that this particular statement is true. Once again, guys, follow your steps. All set bachalo. First step, putting n equal to 1, what will be LHS? 1. What will be RHS? 1 into 1 plus 1, 2 into 2 plus 1, 3 upon 6. 1 into 2 into 3, 6 by 6, 1. LHS matches with the RHS. That means P of 1 is true. Next, assume P of k is true. If you assume P of K is true, that means 1 square plus 2 square plus 3 square up till K square will be equal to K plus 1, 2K plus 1 upon 6. Third step. Now you'll put n equal to K plus 1, but be careful. If the last term is K plus 1, the term before last one will be K. 1 square plus 2 square plus 3 square plus dot 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 up till K square plus K plus 1 the whole square. Can you see? N is taken as K plus 1. Last term is K plus 1. Before that K. Well. What is this? From step number 2. Always in step 3, step 2 is used. This is your K plus 1 to K plus 1 by 6. K plus 1 to K plus 1 by 6 and K plus 1 the whole square. Go on simplifying it. K plus 1, you can cross multiply and then simplify. K plus 1 to K plus 1 plus 6 times K plus 1 the whole square upon 6. We can take K plus 1 common. Let's see what the RHS looks like. K into 2K plus 1 plus K plus 1. 6 times, right? 6 times K plus 1. K plus 1 by 6. 2K square plus K plus 6K plus 6. K plus 1 by 6. 2K square plus 7K plus 6. Right? This is the LHS so far. Let's find the RHS. That means putting K as N as K plus 1. K plus 1. K plus 1 plus 1 and 2 times K plus 1 plus 1 divided by 6. Solve. K plus 1, K plus 2 and 2K plus 3 upon 6. Okay, does it match with the LHS? Absolutely. If you want, you can keep this K plus 1 by 6 outside and multiply these two brackets. You're going to get absolutely the same thing. K plus 2K, 2K square, 3K plus 4K, 7K and 3 2s are 6. LHS is equal to RHS, boss. P of K plus 1 is true. And if P of K plus 1 is true, it implies what? The given mathematical statement is true by principle of mathematical induction. Alright. Very good. Let's go ahead. Here is another beautiful question. 1 upon 4.7 nahi hai bhai. 1 upon 4 into 7 plus 1 upon 7 into 10 plus 1 upon 10 into 13 up to n terms will be how much? Now this is not your prove that statement. It is not a mathematical statement which has to be proven. It is a mathematical statement where the RHS is missing, you have to find. So obviously those 3-4 steps we will not perform. We don't know the RHS. How to solve? This is an important, nice question. Well, these are all 4, 7, 7, 10. Can you see some pattern? 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13. So, some generalized format if you like to give. With this, I will also like to tell you one thing. Whenever you have two numbers multiplied like this, 1 upon A into B, you can always write it as B minus A divided by, 1 upon B minus 1 upon A divided, and you will write it as 1 upon AB. Did I make a mistake? 1 second. 1 upon AB, right? A minus B upon AB. Yeah, 1 upon A minus B should come here. You can always write it as 1 upon a minus b, 1 by b minus 1 by a. Example, 1 upon 4 into 7, you have to write it. What can I write it as? 4 minus 7, whichever is bigger. You can take the bigger one first. 7 minus 4, 3. Divide by 3 and inside 1 upon 4 minus 1 upon 7. I'll rewrite this. 1 upon b minus a, and over here 1 by a minus 1 by b. b minus a upon. Correct. Absolutely correct. Please box it out. Right. First term can be written like this. Similarly, second term can be written in a similar fashion. 1 upon 7 minus 1 upon 10. Third term, 1 upon 3 times 1 by 10 minus 1 by 13, and so on. Can someone think of what will be the nth term? It's very interesting. 1 by 3 can be taken common. What will be nth term, guys? Next term will be 1 by 13, so on. Okay. These 4, it's on multiple of 3 but with plus 1. 4 is nothing but 3 ones are 3 and plus 1 you get 4. 7 is 3 twos are 6 plus 1 will give us 7. 10 is 3 threes are 9 plus 1 will give us 10. So it's multiple of 3 but 1 added to it. So can I write the first term in general is 1 upon 3n plus 1 in the denominator. And what is the second term? 7, 10. If this is multiple of 3, 3 ones are 3 plus 1, isn't it? 3 ones are 3 plus 4. This is 3 twos are 6 plus 1. This is 3 twos are 6 plus 4, 10. This is 3 threes are 9 plus 1. This is 3 threes are 9 plus 4, 13. So the general term can be 3n plus 4. This is 3n plus 1 and this is 3n plus 4. The two terms in multiplication are like this, 3n plus 1, 3n plus 4. All right. And if I go by the similar logic, it will be 1 upon 3n plus 4 here in the denominator. Got it? All right. Each term is getting cancelled. But first and last will remain. Why? Because this is positive and this is negative. Now, no next term to cancel it. There is no next term to cancel it. There is no term before this to cancel. 1 upon 4 minus 1 upon 3n plus 4. Simplify and you have got the answer. This is 1 upon 3, 3n plus 4 minus 4 upon 3n plus 4. 4, 4 cancel, 3, 3 cancel. This is n upon 3n plus 4. So the given statement RHS will be this, n upon 3n plus 4. This will be the RHS. Understood the logic? Please note this down and try to solve this question again, important. As I said, MCQs in PMI are easy. 1 plus 2 plus 3 up till n will be kn, n plus 1. Then what is the value of k? Very easy. If you know sum of first 10 natural numbers is nothing but n plus 1 by 2. If you know this formula, then directly compare. They have given it to be equal to k n plus 1. What is k? Compare, Praful. K is equal to half. But then what if you don't know? What if you don't know the RHS? How will you solve such a question? Now to solve such a question, you can always take the different values of n. Put n equal to 1. What is LHS? 1. And what is RHS? K, 1, 2k. Now LHS should be equal to RHS. Why? Because the given statement is true. P of 1 is true. P of 1 is true. That means LHS should be equal to RHS. 1 equal to 2k, k equal to 1 by 2. So if any question is given and you want to find the value of unknown, put n as 1 or n as 2 or 3 or 4. Whatever n you want to put it in the LHS, RHS, you'll easily get the answer. Because it is true statement, it will satisfy for all the natural numbers. 1 is the easiest, that's why I took 1. Let's go to the next set of problems, which is divisibility problems. And the approach to solve such question is a little different. I will be solving 2 questions and those 2 questions will help you understand how to crack the questions, right? One thing that you need to remember, when I say a certain thing is divisible, like 2 is divisible by 4, right? If I say 4 is divisible by 2, not 2 is divisible, 4 is divisible by 2. That means 4 is a multiple of 2. If I say A is divisible by B, that means A is a multiple of B, where K is any constant. If I want to say that they are divisible, one is a scalar multiple of other, or A is equal to BK. Now I am putting the heading divisibility problems. In your textbook there are certain questions of multiplication, but divisibility and multiplication are just reciprocals of each other. So whatever you are doing for divisibility will be same as multiplication. Like if they say you prove that 4 is divisible by 2, in other question they can say that prove that 2 is multiple of 4. Method will remain the same. Method is not going to change. Let me take an example. Here is a mathematical statement, 7n minus 3n divisible by 4. You have to prove this mathematical statement. Guys, the steps are more or less same. 4 steps same. 7 raised to n minus 3 raised to n is divisible by 4. Proof. Okay, boss, let's start with n equal to 1. Now here in such questions there is no LHS, RHS. One thing to note, no LHS, RHS separately. Can you see any RHS? The statement is just a statement. In equality problems, you have equal to, that's why you have LHS, RHS. But in divisibility and inequality problems, you will never find LHS, RHS. No separate LHS, RHS because there is no equal to only. So put n equal to 1. 7 raised to 1 minus 3 raised to 1, 4. And is 4 divisible by 4? Yes. Therefore, P of 1 is true. First statement is true. First statement is true. Check, assume, check. So check is done. First check done. Now second, assume P of K is true. When I say P of K is true, that means 7 raised to K minus 3 raised to K is divisible by 4. And when something is divisible by 4, it is a multiple of 4. M is any constant. Like there it was K, I am writing here M. If this number is divisible by 4, that means it's a multiple of 4. That's why it's dividing by 4. Okay. Third, for n equal to K plus 1, you will be checking. Check, assume, check. So put n as K plus 1. We don't know whether it is divisible by 4 or not. You have to prove. And how? Can I write this as 7 raised to K into 7 minus 3 raised to K into 3? Alright, very good. Always in third step, we use the second step, right? 7 raised to K minus 3 raised to K. I want 7 raised to K minus 3 raised to K here. Let's do one thing. Add and subtract 7 raised to K into 3. Uh, 7 raised to K minus 3 raised to K. Not minus 3 raised to K. If I take 7 common, okay, it has to be 7 common, 3 raised to K, 3 raised to K. Yeah, I will add and subtract 7 into 3 raised to k. And how to get this? It's very simple. Let me proceed, you will understand. Add and subtract 7 into 3 raised to k in this. 7 raised to k into 7. Add 7 into 3 raised to k. Subtract 7 into 3 raised to k. And whatever is there already, write it. These two terms are added and subtracted. Why do we add and subtract this term? Because from here I can very nicely take 7 common, and inside the bracket 7 raised to k minus 3 raised to k is left. And that is 4m. That is 4m. So in order to use this step 2 in step 3, we wanted 7 common. And because we wanted 7 common, we took 7. And inside we wanted 3 raised to k, that's why 3 raised to k. So 7 into 3 raised to k, that's how it comes. From your 3 raised to k is taken common, minus 3 raised to k I would say. Inside the bracket, 7 minus 3. We will do one thing, this should be subtracted and here added. So we get a minus sign. 7 times this thing is 4m minus 3 raised to k times 4. Overall, can you see 4 can be taken out? Yes. Inside 7m minus 3 raised to k. Somehow we have shown that this LHS is a multiple of 4. Have you shown that LHS is a multiple of 4? This extra thing is D. Let it be any number, anything. But if I can take 4 common, that means LHS we have proven to be equal to multiple of 4. And if it's a multiple of 4, it is also a divisible of 4. Therefore, 7 raised to k plus 1 minus 3 raised to k plus 1 is divisible by 4. And if it is divisible by 4, p of k plus 1 is true. And if p of k plus 1 is true, the given statement p of n is true. What is p of n? 7 raised to n minus 3 raised to n is divisible by 4. Is it true? Yes, it is true by principle of mathematical induction. Please understand it very carefully, everyone. The 3 steps don't change. Method changes a bit because no LHS, RHS, we put n1. First step true, second step assume, third step. In third step, this is crucial. Adding and subtracting. 7 into 3 raised to k. How do we understand? Because somehow 7 raised to k is there. We want minus 3 raised to k. We want. And how do I bring that? So adding and subtracting 7 3 raised to k. 7 will come out. 3 raised to k inside. 3 raised to k out inside. And then minus 3 raised to k I've taken in. This is what we get. Overall 4 common. Whatever is left inside, give it some name, any constant, and question is done. Let's solve this question where you have to show that that particular statement Pn is divisible by 25. Process remains same. Put n for n equal to 1, 49 raised to 1 plus 24 raised to n minus 1, 0. That's 49 plus anything raised to 0, 1, 50. Is it divisible by 25? Yes. Therefore, P of 1 is true. Guys, Wallah, first step, done. P of 1 is true. Second step, assume P of k is true. That is 49 raised to k plus 24 raised to k minus 1 is a multiple of 25. Right? Assume means it is divisible by 25. It is 25 times n. Third step, for n equal to k plus 1, what is the given thing? 49 raised to k plus 1 plus 24 raised to k plus 1 minus 1, which is 49 raised to k into 49 plus 24 raised to k only. Okay, somehow we want to use step number 2 here in step number 3. 49 raised to k is there. We want 24 raised to k minus 1. So what should be added and subtracted? Add and subtract. This 49 is common. Take that. And what is missing? 24 raised to k minus 1. Add and subtract 49 into 24 raised to k minus 1. See how nicely you are going to get the answer. For 49 raised to k into 49, adding 49 into 24 raised to k minus 1 and subtracting 49 into 24 raised to k minus 1. What is left? This 24 raised to k is left. Can I do one thing? 24 raised to k can be written as 24 raised to k minus 1 into 24. Correct? Great. Now a beautiful on your way. Can you see 49 coming out? Great. 49 raised to k plus 24 raised to k minus 1. Step number 2. Minus 24 raised to k minus 1. 49 minus 24. Minus outside. So first term positive, second term negative. This is 49 times, okay, 25m. Minus 24 raised to k minus 1. 49 minus 24, 25. Hola ho, 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 ho. 25 can be taken common, and that's what we want. If it is divisible by 25, we somehow want 25 outside. Somehow just try to take your 25 out. It is 49m minus 24. Write that whole thing here, d. How does it matter? 49m minus 24 raised to k minus 1. Just write this whole thing as d. And LHS, now you have showed it to be a multiple of 25. That is p of k plus 1 is true. And that means the given statement is also true. The given thing is true by principle of mathematical induction. Great. Next question. Lambda is between 2 and 5. Here is a statement. 7 raised to n minus 2 raised to n is divisible by lambda. What is lambda? 2, 3, 4 or 5. Now lambda between 2 and 5. Take different values of lambda. Take lambda 2, put here. 7 raised to 2 minus 2 raised to 7 square, 49 minus 4, 45. Okay. 1 second. Not lambda equal to 2. Take n equal to 2. Take n equal to 3. 7 cube minus 2 cube. By the way, this 45 is divisible by 5 only. No need of checking. As I said, whenever they give you any unknown, in the previous question they gave you find the value of k. So for finding k, we took n equal to 1 and solved. Why n equal to 1? Because it was true for all natural numbers. Here it's not true for all natural numbers, it's true for numbers between 2 and 5. And that's why the answer is, wait a minute, yeah, right? The answer is 5. You could have taken n equal to 1 also. 7 minus 2, 5. Divisible by 5. Because lambda is between 2 and 5. N is not between 2 and 5. I also misunderstood. N can be all natural numbers. They have mentioned it. N is all natural number. So this has to be true for n equal to 1, 2, 3, every number. Take n, anything. We get the answer. 3 raised to 2n plus 7 is divisible by which maximum possible value? Okay. N is natural number, so take different values of n. Put n as 1. 3 raised to 2 plus 7. 9 plus 7 is 16. N equal to 2. 3 raised to 4 plus 7. 3 raised to 4. 81 plus 7. 88. N equal to 3. 3 raised to 6 plus 7. 3 raised to 6 will be your 729 plus 7, 736. They've asked you which maximum possible value. Okay, so all of them are divisible by 8. This is divisible, yeah. 16, this is divisible, this is not. 24, first one is not divisible. 1, everything is divisible. So I want the maximum. 16 is dividing this one. Just check. 16 5 is 80, so 16 4 is 64, 96. Yeah, 16 is dividing this. What about this? 16 is not dividing the middle one, so it's not there. 24 is not dividing all. 8 and 1 are dividing all of them. So the given mathematical statement is divisible by 8 as well as 1. We want the maximum. Maximum answer will be 8. The biggest one, answer is 8. That was all about your divisibility problems. Now let's run to inequality problems, which is again no LHS, RHS and a special approach. A lot of common sense will be used here. A lot of common sense. Let me talk a little about it. Suppose you're dealing with questions of inequality. One thing for sure you should know, if A is less than B and B is less than C, can we say A is less than C? Yes. And similarly, if A is greater than B, which is greater than C, then A is greater than C. This common sense logic is going to be used a lot in questions of inequality. Let's do it. P of n, 3 raised to n is greater than n, right? Prove that P of n plus 1 is true. Prove P of n plus 1 is true. Great. P of n plus 1 is true. That means what you have to prove, actually 3 raised to n plus 1 is greater than n plus 1. That's what you have to prove. Let's go easy, step by step. In this, multiply by 3. Why am I multiplying by 3 both the sides throughout? So I get 3 raised to n plus 1. So multiply by 3. 3 raised to n into 3 is greater than n into 3. Powers will get added. 3 raised to n plus 1 is greater than 3 times n. 3 raised to n plus 1, I want it should be greater than n plus 1. Here it's 3n. Isn't it a common sense? N is a natural number, by the way. N is a natural number, not mentioned, but if it's not mentioned here, we will consider in this chapter n as natural number. Now, isn't it a common sense? From n plus 1 and 3n, which one will be greater? 3n. If you can't understand, take n on the other side. 2n is greater than 1. That means n is greater than half, and it is true. N is a natural number, it will be more than half. So saying this is absolutely correct, that 3n is greater than n plus 1. 3n is greater than n plus 1. 3 raised to n plus 1 is greater than 3n, which is again greater than n plus 1. From this, A is greater than B, B is greater than C. Can I say A is greater than C? Hence, proved. Hence, the question is solved. Check out. Try to understand what happened just here. A greater than B. We want to prove A greater than C. So, try to prove B is greater than C. A is greater than B given to you. You want A is greater than C. So, try to show that B is greater than C. A greater than B greater than C. You will get A greater than C. So, we showed B is greater than C. Next question. 2n is less than 2 raised to n. Then show that P of n is true. Now, here we will follow all these steps religiously, all the 4 steps. Yes. First, for n equal to 1. 2 is less than 2 raised to 1. Yes. No, it is not true. False. Find the smallest positive integer for which this is true. So for n equal to 1, it is not true. For n equal to 2, 2 into 2 is less than 2 raised to 2. 4 is less than 4. No, it is also false. Third one. For n equal to 3, 2 into 3 is less than 2 raised to 3. 6 is less than 8. Yes, true. So what is the smallest integer for which this statement is true? It is true for n equal to 3. For n equal to 3, the given statement is true. The given Pn is true. Question done. 2 raised to n is less than 1 into 2 into 3 into dot 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 m. This is multiplication. What is the smallest positive integer for which this is true? So again you take different values of n from the options. N equal to 1. 2 is less than, only one term will come. 2 is less than 1, no, false. First option out. Put n equal to 2. 2 square is less than, take 2 terms, 1 into 2. 4 is less than 2, false. N equal to 2 out. Take n equal to 3. 2 cube is less than 3 terms, 1 into 2 into 3. 8 is less than 6. No, false. N equal to 3 out. So it has to be n equal to 4, but check. 2 raised to 4 is less than 1 into 2 into 3 into 4. 4 terms in RHS. 2 raised to 4, 16 is less than 2 3s are 6, 6 4s are 24. Yes. For n equal to 4, the given statement becomes true. So that is the least value for which mathematical statement will be true. Right? Very nice. Next question. Prove that the statement is true by principle of mathematical induction when n is greater than or equal to 3. When n is greater than or equal to 3, only then this particular statement is true. 2n plus 1 less than 2 raised to n. Okay, so lowest value is 3. First step, for n equal to 3, you will check. 2 3s are 6 plus 1 is less than 2 raised to 3. 7 is less than 8. P of 3 is true. First step done. Second step, assume P of k is true. Put n as k. 2k plus 1 is less than 2 raised to k. What do you have to prove? You have to prove 2 of k plus 1 plus 1 is less than 2 raised to k plus 1. Ultimately, this is what we have to prove. Or if you open up, 2k plus 3 is less than 2 raised to k plus 1. If you are able to prove this, which is the third step, then fourth step you can conclude therefore Pn is true by principle of mathematical induction. You can prove, if you can prove this, you can conclude that given statement is true. But obviously for n greater than or equal to 3. First step, second step. How do I bring k plus 1 here? The only way to bring k plus 1 is multiplying by 2. Throughout. Left side also and right side also. Both sides multiplying with a positive number, it's absolutely fine. Left side will be 4k plus 2 is less than 2 raised to k plus 1. Now instead of 4k plus 2, you want 2k plus 3. Isn't it very, very obvious, man? That 4k plus 2 or 2k plus 3 is less than 4k plus 2. Think about it. If you are not sure, then rearrange this. 3 on the other side, k on the other side, 2 on this side, 1 less than 4k minus 2k. 1 is less than 2k, that is k is greater than half. K is greater than half, and it has to be greater than half because we are dealing with natural numbers. K plus 1, k has to be more than half. So let's, if you want to understand it fully, just rewrite this. Okay, you will assume that this is B less than A. B is less than A, and you just proved that. You just proved, guys, B is greater than C. So B is less than A and C is less than B. B is less than A and C is less than B. Can we say C is less than A? If B is less than A and C is less than B, automatically C will be less than A. What is C? 2k plus 3. What is A? 2 raised to k plus 1. This is C less than A. And once you have proved this, 2k plus 3 is less than 2k plus 1, you have proved that P of k plus 1 is true. And if you prove the third step true, fourth step can be concluded. Given statement. This is your P of n. The given statement is true by PMI, by principle of mathematical induction. It's true. Question is solved. Done. Let's do one last question on inequality. What they are? Let's get that feel. Using principle of mathematical induction, this particular inequality has to be proven for all natural numbers. X is greater than minus 1. Alright. Taking n equal to 1. 1 plus x raised to 1. Is it less than or equal to 1 plus x? This relation is true. 1 plus x is less than or equal to 1 plus x. P of 1 is true. Great. First step, check. Done. Second step, assume. Assume P of k is true. That means for n equal to k, 1 plus x raised to k will be less than or equal to 1 plus kx. Okay. Second step, assumed. Third step, what you have to prove? TPT to prove that for n equal to k plus 1, 1 plus x, the whole raised to k plus 1 will be less than or equal to 1 plus n. In place of n, you will put x. That is, in other words, you will prove that 1 plus x raised to k plus 1 is less than or equal to 1 plus kx plus x. Or in other words, 1 plus x raised to k plus 1, you will prove it is less than or equal to 1 plus x plus kx. This is what you have to prove. We haven't yet proved. And in inequality, that's how we always try to do. Step 1, step 2, and step 3 directly we write, and now we try to fulfill the gap between step 2 to step 3. How do I convert this so as to prove this thing? Okay. 1 plus x raised to k is there. I want 1 plus x raised to k plus 1. It makes sense. Multiply by 1 plus x throughout. Great. Now you are understanding the common type of logic. Less than equal to 1 plus kx into 1 plus x. This is 1 plus x raised to k plus 1 less than equal to, open up, 1 plus x plus kx plus kx square. 1 plus x raised to k plus 1 less than equal to 1 plus x plus kx plus kx square. Brilliant. Can you all already see the answer? Because I can. This is A less than equal to B. A less than equal to C is what I have to prove. That means just try to prove. We have A less than equal to B. If I show B is less than equal to C, I can easily say that A is also less than equal to C. I have to prove this, A less than equal to C. So try to show this part. It is obvious. 1 plus x plus kx plus kx square. Isn't it going to be less than or equal to 1 plus x plus kx? Why? Because kx square is a positive number. Kx square is greater than equal to 0. Always. X square is going to be either greater than equal to 0. So LHS, this part is equal to this part. LHS, RHS, these two parts are same. In LHS, there is an additional term. So that means, hey, B is greater than or equal to C is what I'm getting. Okay, let's try to get this sorted. If I multiply, putting x as k plus 1, A is less than equal to B, and B is greater than equal to C is what I'm getting. Okay. So just now I realized that this is not possible. There is something wrong, and that wrong is the question. The question is wrong. The sign in the question is wrong. We have copied a wrong question, and it's majorly my mistake, but we also learn. Here it should be greater than equal to. That's the inequality. If the inequality I reverse, question will be solved. It fits well because otherwise it's not possible. So A is greater than equal to B. Hang on. Right. We have got A is greater than equal to B. Here also it will change. We want A to be greater than equal to C, isn't it? We want A to be greater than equal to C. A is greater than B. How will A be greater than C? If B is greater than equal to C is shown. If A is greater than B, B is greater than C, automatically A will be greater than C. So we already showed it. This is your B. Can you see? And also this sign will change because if everything is changing, yeah. Obviously 1 plus x plus kx square will be greater than 1 plus x plus kx because there is an extra term in LHS. LHS is greater than RHS. B is greater than equal to 0. Therefore, it automatically applies. From here and from here, it automatically applies 1 plus x raised to k plus 1 is greater than or equal to 1 plus x plus kx. This is automatically applied. And therefore, P of k plus 1 is true. If P of k plus 1 is true, the given statement is obviously true by principle of mathematical induction. The inequality questions are really very nice, easy, simple. Once you understand this ABC relation, inequality relation, questions will be sorted. Last question, and I think I'll be very satisfied to finish this chapter. Summarize this chapter from my side. If it was teaching, I would have taken more questions, but the gist overall has been already given to you. If n is a natural number, MCQs are so easy in PMI. When n is what? Greater than 1, greater than 2, greater than equal to 1, or greater than equal to 2. What is the relation? N plus 1 by 2, the whole raised to n is greater than n factorial. Okay, let's take n equal to 1 and put here. 1 plus 1, 2 by 2 is the LHS. LHS is 1. And RHS is 1 factorial. What is 1 factorial? 1. So 1 is greater than equal to 1. So for n equal to 1, it is true. It is true for n equal to 1. That means option 1, C is correct. N greater than equal to 1. If you want, you can check it for 2. 2 plus 1, 3 by 2, the whole raised to 2 is greater than equal to 2 factorial. 3 by 2, the whole square, that's 9 by 4 is greater than equal to 2. Obviously 9 by 4 is greater than equal to true. So it's true for 1, 2, 3 and so on. So these many things we did. Introduction to PMI, deductive, inductive. Remember Vinay, naughty, yes. Motivation, the domino effect. One box falls on the other. Mathematical induction. What is PMI? The principle, the steps we saw. Working principle, equality problems, divisibility or multiplication problems, and inequality problems. That was all about this chapter. Beautiful chapter, PMI. I wish it would have been there in your syllabus, but in the syllabus of boards, but it's been removed. So be happy and learn it for fun. That's it from my side, guys. Thank you so much. See you next lecture. Bye bye.